Hey, welcome back to codezing.org. Got another level 3 project. This one's Guess the Computer's Number. You can find it at codezing.org/guess_number. So let's navigate over to the website, codezing.org, level 3, and we are going down to Guess the Computer's Number. So the computer will pick a number between 1 and 10, try to guess it. Okay, so I guess 5. Guess a lower number. Guess again, your last guess was 5. Alright, a lower number, 4. No, a lower number still, 1. A higher number, 2. Oh, we're closing in. It's got to be 3. 3, yay. Alright, great job. That's right. Want to play again. So kind of cool. I think the game is fairly simple. The game itself is maybe a level 1 game, but giving more advanced user feedback is why I put it in level 3. So evaluating the user's guess and giving them back whether they need to guess higher or lower, and then ending the game when they make a correct guess, I think is a little bit more of an advanced feature. So let's take a look at the code and see how it accomplishes a little bit more robust feedback to the user. You can click on the button. Let's copy the code and paste that into Spider. If you don't have Spider or Python, you can head back to the website, follow the links to get Python, but you should probably be at a lower level if you haven't installed Python yet or you're not familiar with getting it installed. Let's take a look through the code here. So we're importing random again, and that's going to be picking the computer's random number. So that's what this first step does. Random.randomInt. It's going to pick a random integer between 1 and 10. Obviously, you could expand the game to pick higher numbers. I just did it 1 through 10 to make it a little simpler, but you could have them guess any range that you want. We're going to employ a while loop to make the game continue until they get a match, right? So we can see we're setting done equals to false to start, and then while done is equal to false, it's going to play the game. It's going to loop through all the game, and then at the end, if the player guess ultimately is equal to the computer's number, it's going to set done to true, and that will end the game. So that's what the while loop is doing, and then everything that's indented from the while loop is what will run while this statement evaluates as true. So until done is not equal to false, it'll keep running. We've also got some try and excepts in here. So if you remember, a try will attempt to run this code. If it gets an error for any reason, it will run the except code. So if this executes perfectly and there's no errors, then the except code will not run. And so we do try with a colon and then indent for all the stuff we want it to try, and then followed by an except with a colon and then all the stuff you want it to do if the try results in an error. And maybe you could try to think through what could somebody enter in that would make this error out, that would make it fail. It's pretty easy to see that you're just printing to the screen, guess a number between 1 and 10, but a user could enter anything. If they enter a letter, or they enter a symbol, or they enter 99, then I guess if they entered 99, it would accept 99. But if you entered a letter, it would fail because it's trying to convert it into an integer, and it wouldn't be able to. So let's see. So if somebody pressed A or something instead of 1, it would run this except code. It would make done is still equal to false. So it's not changing done, it's just reasserting that done is equal to false. You want the game to continue. You don't want it to stop just because they made a bad guess. And it makes player guess equal to none because they basically didn't put in a valid guess. So let's assume that they do put in a valid guess between 1 and 10. Then the next steps will be to evaluate whether that number. So I guess this is the clause I was saying. If they entered a number 99, it would fail, but it wouldn't fail up here. It would come down here and say if the player's guess is not in the range 1 through 10. And remember, one tricky little note on ranges in Python, it starts at 1 and then goes up to, but not including the last number. So up to 11, but not including it, is 10. So it's always kind of one integer down. So if the player guess is not in the range 1 to 10, then print to the console, that's not an acceptable guess. You must pick a number between 1 and 10, and then reassert that done equals false. So this is a little redundant, but I put it in here just to track when is the game going to end. At each one of these steps where done equals false, the game does not end. It will continue this while loop. So this handles the case a player enters a number but not 1 to 10. This try and accept handles the case a player enters a letter or something that's not a number. And so we've kind of captured two big mistakes that the user could do and give them feedback of what they need to do to continue the game. And you could even, if you wanted, you could give feedback here as well. If they put in a letter, you could also have that print out. That's not an acceptable guess. You must pick a number between 1 and 10. So we've handled two cases where they would put in bad information, and then this loop here handles, or this logic test handles if the player does guess in the range between 1 and up to but not including 11, so 1 through 10. If the player does successfully guess between 1 and 10, let's figure out whether they won or not. So if the player's guess is equal to the computer number, remember 2 equal signs is the test of whether player guess is equal to computer number. 1 equal sign by itself sets a variable equal to something. So done equals false sets the variable done equal to false. This tests whether player guess is equal to computer number. So 2 equal signs for that. So if the player's guess is equal to the computer's number, right? And remember, computer number is the random number we picked at the beginning. Then print, great, that's right, and set done equal to true, and that will stop the game, right? Because this while loop will no longer be false. Done is equal to true now, and so this will quit looping. If it's not equal, right? This is elif, stands for else if. It's like the next step. So if the player guess is equal to the computer number, do this. Else, if the player guess is greater than the computer number, so this would be the case where a player guessed too high, we want to print guess a lower number and reassert that done is false so that the game continues. If that's not true, then do the next step. Else, if player guess is less than computer number, print guess a higher number. Done equals false. So we've, within this loop, took precautions against people putting in bad information and then put in the logic of what to do if they put in the correct information. So let's run it and see about putting in bad information. So let's see, bad guess. You see it says that is not an acceptable number. You must pick a number between 1 and 10. For some reason I printed that twice. I guess maybe that's why I didn't have this in there in the first place, because this also does the same thing, because bad guess is also not in range 1 through 11. So that's why I printed out twice. So I guess I had it right the first time. And that's how you figure out what you've done right and wrong in your code. You run it, you see what happens, you go, oh, messed that up, let's fix it. So we'll run it again, and this time I'll put in some symbols. Oops, if it's going to let me. It seems to have locked up on me. So if the game locks up on you, you can hit this stop button. Will stop the game from running. Let's see. Now is it gonna there? Now it's gonna let me guess. But it didn't restart after my fix. So you can always go up to consoles and then restart kernel. That does like a full restart of Python, where Python will start over just like you've just opened the program. Sometimes if it gets tangled up in whatever code you're running, or your loop doesn't end if you forgot to put in this done equals true and it keeps asking you even though you've got it correct, you can hit the stop button or you can restart the kernel. Let's give it a run. Alright, so let's say I put in symbols. Let's see, that's not an acceptable guess. So that's working. What if I put in 99? Right, that's not an acceptable guess. Negative 2,309. That's not an acceptable guess. How about just 11? Nope. 0? Nope. Alright, so we seem to have caught all the cases where somebody could try to enter something they're not supposed to, which is great. It keeps the game from erroring out. And now if we make a guess, let's say 5. Oh, well, 5 was right. So game over. If we started again, I guess 5. Let's see, guess a higher number. So it must have fallen into this loop. If my guess was in range 1 through 11, and my player guess is less than the computer number, then print guess a higher number. So I got guess a higher number. So we'll do 6, 7, and we found it. So very cool. Lots of interesting stuff. I think, as you build the games, and maybe you found out building the level 1 and level 2 games, if you put in the wrong information, when the query was made to get the input from the user, if you put in the wrong information, it would just kill the game. You'd get an error, and it would stop the game. This is pretty robust in a couple simple steps to rule out any, mistyping or erroneous entries. And continue the game until somebody actually gets the right guess. So we'll be doing a lot more of that in the level 3 games, building in checks to make sure that the user isn't going to break your game. And even then, even after you think of all the stuff you can think of how a player can break your game, once you let people start playing it, you'll be surprised at what they do to break your game, and you'll have to think through how to put in some more code to catch those exceptions. But alright, have fun with this one.